Hello. Hi. Good evening. Anybody is there? Respond. Hello. Yes. Good evening, all of you. Yeah. Good evening, Nikhil. Any others? Shall I start now? Okay. Okay. Look at this. This is the center of mass. Just quick revision. I will not give much more. I will not take much more time. Just what is what. That's all. So look at this. So look at this circular ring. Center of mass is center. These are the followed by the line of symmetry. The material which is followed by the line of symmetry property. Center of mass is exactly center only. Okay. Position of center of mass. I think this is finally we have to know. This is the center of mass. This is the center of mass. Now this is r, that means this distance from m1 to center of mass 2, and r2 is distance between m2 to center of mass. So look at this is the coordinate system. Center of mass along the x-axis, center of mass along the y-axis, center of mass along the z-axis. Now we have to go important point here. This effect of external force on center of mass. If external force is 0, there is nothing effect on the center of mass. Okay, external force is 0, center of mass will not change. Due to the internal force, it will not affected. External force only affected on the center of mass. Characteristics of center of mass. Yeah, this is it's not required. Methods of center of mass. One is method of symmetry, another one is method of decomposition, next one is method of using theorem of it's not required, method of integration. This is one of the important formula to find out the. So these are the, yeah, this is most important. Look at this. These are the two spheres having the same mass. The center of mass of this, here densities we have to equate it, right? This is circular disc, this is spheres. So sphere circular disc difference is here cube, here square root, that is the difference. Yeah, this one upper. Yeah, this is method of decomposition. That means if I will take, we have to find out the center of mass of first one to center of mass of second one, we have to add, that's all. Okay now, right? Okay, Nikhil. Okay, next. See here, this is the disk and this is the solid sphere. This is also one of the important. Final formula is xn equals to 1 by 2n. Next, this is important to shift center of mass. If it is removed portion, white color is the removed portion. Before removing this is the center of mass. After removing the center of mass is shifted here. So that is the direct formula is, this is x shift equals to shift of the center of mass equals to mass of the removed into distance from center of mass to removed portion center of mass. This is d is nothing but center of mass, original center of mass to removed portion center of mass, then total mass by removed mass. This is important. Based on that we have a so many things left. Tomorrow one question from this, notice that kandipa one question they will ask. Okay na? So be carefully watch this, all the things we have to watch carefully. One question they will ask, I expected they will ask one question from this, either direct question or numerical questions. So watch carefully. So this is the first case, second case, these are the remaining cases. From that, this is note 2.214 is very very important, right? 2.214 is 2.14 is very very important. Okay now, watch carefully. Right? So look at carefully. So here what is the difference? 2.14, 2.14. So edge and radius is half of the radius of the big circle. Okay na? This is the final formula, x shift equals to r by 6. Okay, right? So this is this is not a edge, but this is the edge, and this is the edge. The diameter of this removed portion is radius of the bigger circle. Okay na? That is the difference here. Look at this. So this is also one of the important, right? So we have to notice that this is square plate is removed here. Square plate, square portion is removed. From that, x shift equals to r by 2 into 2 pi minus 1. 2 into 2 pi minus 1. This is the formula. Right. Similarly, the square plate here itself, uniform square only this is. From that square we have to remove that square plate. So that's why L by 3 root 3. Right. Next one is, so this is the square plate. from that they removed circular portion. So for that pi l by root 2 16 minus pi, right? So moment of inertia of rotational motion here also important. Moment of inertia, I moment of inertia equals to mass into square of the distance between them, right? So radius of gyration k equals to root of r1 square plus r2 square and so on rn square by n. So perpendicular axis theorem, Iz equals to Ix plus Iy. Parallel axis theorem, I equals to Ic plus Ma square. So this is Ic or Ig, this is Ma square. A this is. Okay. So next, yeah, this is important. Uniform rod, linear rod. The linear rod which is having the center of mass is exactly middle of the uniform rod. So the moment of inertia is I equals to m l square by 12. So I am not deriving here because of it's no need, no, it's not a time, much more time. So we have to revise all formulas quickly. So if you know this is, if you know this is, it is very easy to uh, understand this. We have to take it, this is one of the, right? So I will show you. So look at this, this is another axis of rotation is edge. So this is, we have to follow here parallel axis theorem. So look at this parallel axis theorem, this is m, right? So look at this mr square, sorry, I'm not showing wrongly, I shown wrongly. Yeah, so here mr square by 12 plus mr square by r is l by 2, m into l square by 2, l by 2 whole square, then we will get it. Yeah, Daniel, I'm giving quick revision, revise uh, regarding the, yeah, good evening pa Daniel, good evening. So system of particles quick revision, so just all formulas I'm going to revising you, so just remember. So this is the circular ring. Circular ring, moment of inertia at the center is I equals to mr square. Next, this is the moment of inertia I at the axis of rotation center and perpendicular to its plane. So this is the circular disc, not a ring. It is a disc. Disc is mr square by 2, right? So this is solid sphere, not a solid sphere. Yeah, solid sphere, 2 by 5 mr square. Next, moment of inertia of the halo sphere. So this is 2 by, sorry, halo sphere is 2 by 3 mr square halo sphere. Then the moment of inertia at edge, 2 by 2 by 3 mr square plus mr square, 5 by 3 mr square. This is okay. So this is regarding about the moment of inertia. So next, rotational motion. So look at this rotational motion, right? Angular displacement, this is important conversion of a 1 radian equals to 360 by 2 pi, that equals to 57.3 degrees. So angle equals to arc length by radius. Okay, average angular velocity, this is the formula. Instantaneous angular velocity, this is the formula, right? So look at this, a body perform n rotations in time interval, then its average angular velocity is omega by, omega equals to 2 pi n by t, right? So look at this quick revision. So angular velocity of a seconds and seconds hands complete one revolution. but second hands complete one revolution, it will take a 60 seconds, one revolution. Omega equals to 2 pi by time 60 seconds, that is pi by 30 seconds. Next, minutes hands complete one revolution in 1 hour. So minutes hand 1 hour sorry minutes hand complete in 1 hour 360 seconds, 2 pi by 360 3600. So pi by 1800 radians. So next, hours hands 2 pi by 12 into 12 hours into 1 hour equals to 3600. Similarly, earth is 2 pi by 24 into 1 hour equals to 3600. Right. So angular acceleration. So look at this, this is the acceleration, right? Instantaneous acceleration, average acceleration. So angular velocity d theta by dt, right? So next, this is the relation between the linear velocity, angular velocity. V equals to r omega, right? So this is the relation between the translator circular motion, translator motion, circular motion. So what are the four equations? V equals to u plus at, s equals to ut plus half ad square, v square minus u square equals to 2as, like that. So here also v2 equals omega 2 equals to omega 1 plus alpha t. Alpha is nothing but angular, sorry, this is angular acceleration. Similarly, theta equals to, theta is the angular displacement, omega 1 t plus 1 by 2 alpha t. Omega 2 square minus omega 1 square equals to 2 alpha theta. These are the usual equations. So next to torque, torque formula pa, torque tau equals to r into f sin theta. Next, couple and moment of couple, two equal unlike parallel forces whose lines of action are not same constitute a couple. So that is the relation between the torque and angular momentum. This is the torque tau equals to I alpha. Torque tau equals to I alpha. Next, law of conservation of linear moment. Already I told you, no. So this is moment of inertia and angular velocity. Already I told you. So this is while rotating time. He was stretching his hands. Moment of inertia is increasing and angular velocity decreasing. While closing the hands, moment of inertia is increasing. Sorry, moment of inertia is decreasing and angular velocity increasing. Here angular velocity increasing, here moment of inertia is increasing. So like that. So this is the rotational kinetic energy and translational kinetic energy. K equals to 1 by 2 I omega square. Similarly, 1 by 2 L omega. Similarly, L square by 2I. See here, just comparison between the linear kinetic energy and rotational kinetic energy. Okay, now next, work energy theorem. So look at this. This is 1 by 2 I omega square minus. So tau equals to torque into distance. Yeah, tau equals to force into distance equals to 1 by 2 I omega square minus 1 by 2 I omega naught square, right? Okay, so power instant, the rate of doing work. This is the power formula, P equals to dw by dt. D by dt of tau into distance. This is the perpendicular distance, right? So it's a right average power, right? Okay, now this is the rotational motion. So it's not a rotational motion, it is the rolling motion. Rolling motion equals to sum of the pure rotational motion and translational motion. Rotational motion and translational motion. So here rotational motion, this each and every point the angular velocity is different, but translational motion each and every point angular linear velocity is same. The combination they given here pure rolling motion. So this is important condition. V so this is center of mass. The speed of velocity of center of mass equals to r omega. Wheel in wheel is in a pure rolling. We, at this point, at a point, this is they're asking at a point. V velocity of a center of mass is greater than r omega. It slips forward, then it slips backward. So look at this a little bit time. So condition, it is important condition. Okay, these are the different cases, right? And also here it is maximum velocity. Here it is the sometimes three different cases are there. So first case, 0, the angle between the linear velocity and linear velocity and angular velocity is 0, means vcm equals to ve, and 180 means vr equals to 0. 0 means 2v, 90 means root 2v. So these are the positions. So this is right maximum. This is some certain angle like that. Okay. Next, kinetic energy of a rolling body. This is kinetic energy 1 by 2 mv square into 1 plus alpha. So this is the kinetic energy. Translator kinetic energy, rotational kinetic energy. Translator kinetic energy 1 by 2 mv square, that equals to 1 by 2 mv square. Here rotational kinetic energy 1 by 2 I moment of inertia into omega square. 1 by 2 m omega, we have to replace it. I is replaced by the mk square. Omega also replaced by the v square by r square. So if we substitute here, we got it k square by r square, we got it. So that is, instead of that k square r square, we have to take a beta. Then here from this 1 by 2 mv square plus 1 by 2 mv square, if we take a common, 1 by 2 mv square 1 plus beta. This is okay now. Nickel. So this is regarding about the kinetic theory of gases, not a kinetic theory, but rolling motion. Or next, we have to go to the gravitation. Okay now, who are watching, please answer me. It is okay now. Hello students. Hello students. Who are watching? Like. Okay. System of particles and rotational motion, it is completed. Remaining we have to prepare our own, right? Thank you. Thank you. Prepare yourself, pa. Thank you. I'm closing the live. Okay na? Hello. Nikhil, Iruka Nikhil. Hello, anybody is there? Okay. Thank you.